Today we are going to talk about measures of central location and dispersion. We will talk about the mean and the median and the mode. But we will also uh, illustrate applications in business and discuss partially the homework assignment if we have time. If we have time. This is an application, so I'm going to start from basic principles. So I'm going to start this here and bring up something else.
Warehouse office hours 7 p.m. It's 6:15 p.m.
Now, today we're going to talk about the measures of central location. The emphasis will be on the mean. Okay, the emphasis will be on the mean. We will practice how to calculate a simple mean and then a weighted mean. Okay, we will calculate a simple mean and a weighted mean. Now, I'm going to say, for example, you have data here on the price of houses in a neighborhood, the price of houses in a neighborhood. You also have data on the year that houses were sold, the amount of living space in square feet, the lot size in square feet, the price per square foot. You can use any of these to calculate mean, the average. An average is very easy to calculate. A simple average is very easy to calculate. In that regard, I'm going to cut and paste limited quantity of a limited amount of the data. Are you seeing my screen?
Yes, Professor, we can see.
Okay, all right. So I'm going to cut this data and I'm going to paste it. Okay. Very simple average. Okay. An average, simple average is simply you add you get the sum of the listed data, and then you get an average by simply dividing by the number of observations. So let me see if I can get the number of observations here. Okay, so we have 18 observations. We have 18 observations. So what is the average price per house? The average price per house is you get the sum, average, or mean, is simply the sum of values divided by number of observations. That's it. There's nothing magical about it. Okay, the sum of values divided by the number of observations. And so, what is the sum of these values? Easy with Excel. Sum equals sum, and you go from here to there, and so that is the sum of the values. The number of the size of the sample or the population, and so average is equals E22 plus E21 over 18. That is the sum. The average is 424,000. You can also get that average in Excel by simply saying equals average you can sum, you get exactly the same thing. Okay, you can easily get it in Excel that way. This is called the simple average. Okay, but sometimes you have what you call weights. That is to say, let us say that you have some of these all of these prices all repeated. Suppose you have more than one house that is 536,000. You have more than one house that is 413,000. So let us look at weight, or how many observations. So I'm just going to put arbitrary 5, 15, 20, 12, 10. Let us see what happens here. Okay. How many houses are we looking at? Okay, there are 100 houses between the beginning and the first 10 rows, 100 houses. So this is the sum of observations, okay? This is the sum of observations. And so here, a weighted average a weighted average is actually the sum of the values times their weights, okay? Sum of values times weight, multiplied by their weight. And so here you have W. Wx is simply the weight of each value here. So this will be equals 5 equals F3 times U3. Okay. So there are 5 houses that have a value of 536,000. There are 8 houses that have a price of 198,000. You can bring it down. And so here the sum of the observations is 100. So there are 100 houses altogether. And so now the weighted average is sum of the values and their weights divided by the number of observations. Okay. So that is a weighted average. So how do you go about that? The sum of the values times their weights will be equal to sum and average will be equals H11 divided by G12. We use, sorry, F12, not G12. All right. And so you have 460,590. That will be the equivalent of the weighted average. Now, in statistical analysis, we calculate averages. The question is, what do we do with it? Okay, we calculate averages. The question is, what do we do with the averages that we calculate? Okay, they're very, very useful. The simple average or the weighted average is a measure of central location. It is the first line of descriptive statistics. So I'm going to stop share this and pull up some examples, and then let's go and try to look at some applications of this kind of information. You had a homework assignment, not actually a homework assignment, but an illustration. Let me see, not illustration. I'm going to share. Here's a very simple example of weighted average, okay? This is a weighted average for what we call data with a range of values, okay? With a range of values. For example, here, we look at the two neighborhoods, Bronx and Queens, okay? Two neighborhoods, Bronx and Queens. We look at a range of values here of the ages of people living in the two boroughs. To calculate a weighted average that, for example, in some surveys, you can see they ask you your age and they give you a range. Are you between 20 and 25, 26 and 30, 31 and 35, and so forth and so on. And what they want you to do is to take a range. But what if you have that kind of data? How do you calculate a weighted average? The first thing you do is for each range, you calculate what is called a midpoint. And you can see that it's M, okay? That's M. Now, then you use that midpoint, the average will be, you see here, Bronx, 16,000 people have a range. I mean, their age is between 0 and 13. 39,000, their age is between 14 and 33, and so forth and so on, okay? So the midpoint for 0 to 13 is 6.5, and it is 23.5 for 14 to 33, and so forth and so on. So the average, as you can see here, I calculate the midpoint times M times F, and F being the frequency here. The frequency is for the age 0 to 13 for Bronx, the frequency is 16,050. That is the number of people who are between 0 and 13 years. So we'll call that the frequency. And so we'll multiply the midpoint times the frequency for Bronx and for Queens, okay? And so we'll come to an average, okay? The average in statistical analysis, we use bar Y. So bar Y is the sum of see if I can make that bigger. Okay, so the average is the sum of each each midpoint value, times the frequency of that value, which is 16,050 here. And so we have M times F for Bronx here and M times F there for Queens. And so we calculate an average. That average in statistical analysis is called bar Y or bar X or bar whatever value, whatever letter you use to represent the midpoint or the variable, okay? And so on that basis, you can calculate an average. The average age for Bronx is 61, and the average age for Queens is 63, okay? Now, having calculated averages, averages can be misleading. Averages can be misleading. I'll give you an example. Averages can be misleading, okay? Let us say that you have one neighborhood and the values, let us say the income of the people in the neighborhood are 0, 50, and 100. What will be the average? The average will be 50. So the average income in this neighborhood is 50. Let us look at neighborhood 2. Okay, this is neighborhood 2, this is neighborhood 1. And here, the incomes are 45, 50, and 55. The average is what? The average is also 50. Are you saying then that the well-being of people in neighborhood 2 is as good as the well-being in neighborhood 1? The answer quite simply is no, okay? Because you can see that the variation in neighborhood 1 is wider than the variation in neighborhood 2, okay? So the average living standard in neighborhood 1 is not the same thing as in neighborhood 2, because you can see here that in neighborhood 2, there's hardly anybody that is richer than the other, such, okay? But in neighborhood 1, there's 1% that is way up there, and that's 1% that has nothing, okay? So the average, the typical well-being in the two neighborhoods are not the same, just because their average incomes are the same. This is why in statistical analysis, we do what we calculate variation. And so the next thing that we do in statistical analysis is to calculate what we call measures of dispersion, okay? Measures of dispersion. And here we use variance and standard deviation. Okay, we use measures of dispersion, and two measures that we'll emphasize here are variance and standard deviation. We will also calculate the coefficient of variation. We'll also calculate the coefficient of variation. Okay? So, what is our measure of dispersion? How do we measure standard deviation? That is where we start. The standard deviation is the square root of the variance. Standard deviation is the square root of the variance, which you will see here. Okay, this is right? So this is how we measure standard deviation. That is to say, we take the square root of the sum of the values, each value minus the mean, and we square it, okay? And then we take that sum and we square it and we divide by n minus 1. There's a PowerPoint slide that will explain all of this to you. If you cannot find it, let me know and then I'll repost it, okay? And so you calculate the standard deviation. So now, as you can see here, that the standard deviation are different for each group. So I'm going to now pull up a sample of standard deviation calculation and then illustrate how they are used in statistical analysis.
Professor? Yes. Can you pull up back the slide again?
Okay, which one?
The one that you had the formula.
Okay. See if I can look at it. This one?
Yeah, with the standard deviation. What's the F again?
F is the frequency. That's assuming that you have grouped data, okay? If you don't have grouped data, very good. I'm glad you brought up this question. If you don't have grouped data, I'm going to take this formula. This is what I like in a class. Don't just keep silent because I'm assuming that you're following when in fact you may not be following. If you do not have group data, I'm going to take this formula and redo it without the frequency distribution. If you have frequency distribution, yes. If you do not have frequency distribution, I'm going to modify it. Suppose you do not have group data, then this will be I minus bar y, which is you take each one, okay? Let's make that proper. Okay, so you square, you take y minus bar y and square it for each observation, okay? So this is to the power 2, and you divide by n minus 1. So if you have grouped data, you include the frequency. If you do not have group data, you do not include the frequency, okay? Just for each observation, you take the value minus the mean and you square it, and then you get the sum, divide by n minus 1 and get the square root. This becomes the standard deviation. Is it clear what I explained?
So Y is the mean and Y bar is the average weighted mean?
No, okay. Y is each value, and I'm going to go and do an illustration. We are running out of time.
Oh, okay.
Okay, but don't worry about it. I will rather redo this class next week. I start on time. I start earlier, so we have all the time because I need for you to do this correctly because practically everything you're going to do in this class from now to the end is going to depend on this formula. Practically everything. That's it. There's nothing else that you're going to work on. You're going to work on it in different applications. You're going to work on it from different uses of the formula to do different aspects of statistical analysis. Okay, so I'm going to stop in about 5 minutes, but please be in class next week so that I can go through these examples properly. If I start something else, tell me this is not what you said you were going to do, and I will do exactly what I say I'm going to do. You get my point? Okay. So let me see if I can start with something else, another illustration, so as to let's see. Uh, the data to my right. Okay. Are you seeing that? Hello?
Yes, we see it.
Okay. So I'm going to calculate X bar, which is the mean of the values of X. There are no weights, there are no frequencies. Each value occurs only once, as opposed to say each value occurring several times, different levels of frequency. Okay. So X bar is simply the average. So the average is 18.4. All right. So, but this is X minus X bar. So this becomes equal O 3, sorry, O 4 minus O $9 minus O $9. $9. You can see that each value will be deducted from, will be subtracted from the mean. Okay. So 10 minus 18.4 is 8.4. And you get that. You see it? We subtract 10 from 18.4, we subtract 12 from 18.4, we subtract 15 from 18.4, and so forth and so on. And then we square each one. Equals 4 to the power 2. Okay, we square each one. All right. Then we get the sum of the squared values. get the sum of the squared values. That is not the sum of the squared values, but that's the average, sorry. Or sum. The sum of the squared values. The sum of the squared values is 301.2. Okay, the sum of the squared values, and then we divide the sum of the squared values by the number of observations, 1, 2, 3, 4, 5. There are 5 observations. So we divide equals 2, 9 over 5. The sum of the squared values is the variance. That is the variance. And then we take the variance, okay, the sum of the squared values divided by the number of observations is the variance. And so now we take the square root of the variance, which is equals P10, sorry, P11 to the power 0.5, which is the square root. And so the standard deviation is 7.7. Okay, so I'm going to stop here. Okay, I'm going
One question.
you answer your question. Don't worry about it. I'm going to stop here because there's going to be an elaborate lecture on uses of standard deviation. Okay, there's going to be an elaborate lecture on the uses of standard deviation. So I don't want to make it quick. I need for us to really understand it because, like I said, everything else you're going to do in this class for the next 10 weeks is going to be about the mean and the standard deviation. All the ways we can use them to do statistical analysis and then to interpret the results of statistical analysis. Yes, go ahead and ask your question.
Yes, when you were doing the calculations for X, right? And you calculated the number N, do you have to subtract 1 from it?
Yes, that's what the sample standard deviation as opposed to the population standard deviation. Okay, so right here, what I did was actually a sample standard deviation. And so I can actually do this as 4, and that changes the standard deviation. Okay, if you want to make this a sample standard deviation, you can see that the variance changes and the standard deviation also changes. Okay, and we're going to talk about the difference between, I would say, the uses and the roles of the population and the sample as we progress in this class. But next week, I'm going to really start early, and I'm going to elaborate on how we use the standard deviation. I don't want to cut it short because it will not serve us any purpose. Okay, so I'll see you all next week if you don't have any other questions. I'm going to post this. I'm going to send it around, and I'm going to encourage everybody to be in class because you need to understand this in order to do well in this class.